All right, going to do a little implicit differentiation. It asks us to do this, which is notation for the second derivative, and they want it in terms of x and y. And you'll see why they mention that shortly. So we begin this like any other implicit differentiation problem. We take the derivative with respect to x of this, which the first term is just 2x, second term 2y times the derivative of y with respect to x, and that's going to equal 0. We solve that for dy dx. We get, let's see, I'm going to write all the steps in here. 2y dy dx equals negative 2x. dy dx equals negative 2x over 2y equals negative x over y. So let's hold on to that, because that's our first derivative. Let's see, dy dx is equal to negative x over y. Then we'll repeat the process. This is going to require a quotient rule, it looks like. So we're going to take the derivative again. Derivative with respect to x, this time of negative x over y. Recall that the derivative of a quotient is u prime v minus u v prime over v squared. So u prime, I'll carry the negative with the x. That's negative 1 times the bottom minus the top, which is negative x. So that's plus x. V prime dy dx all over the bottom squared. So that is negative y plus x dy dx over y squared. Now they want it in, this is the second derivative now, but they want it in terms of x and y. And we have this uncomfortable little thing there. But fortunately, we know what that's equal to in terms of x and y from up here. We already had the first derivative. So we're going to plug that in. Negative y plus x times negative x over y squared. And that's going to equal negative y plus, excuse me, that'll be a minus now, won't it? Let's see, positive x times that's negative x squared over y squared. Now that's not going to be one of your answers, so we have to clean that up a little bit. Multiply the top and bottom of negative y times y, so we can put those terms together. We get negative y squared over y minus x squared over y squared. which is negative y squared minus x squared over y squared, which is negative y squared minus x squared over y cubed. Still not one of our answers, I don't believe, but we can pull one more little thing out, and let's see, if I pull a negative out of the top, I get this. Okay, and recall that the very beginning of the problem, x cubed plus y cubed was equal to, x squared plus y squared x squared plus y squared was equal to 3. So you see we have x squared plus y squared right there. So that's a little trick. You have that deal up here where you have to sub in for dy dx to get it in terms of all x's and y's. And then sometimes they want you to simplify if it happens to fall out right, and this one does. They want you to simplify a little bit more. So we can substitute the 3 that x squared plus y squared is equal to up here, and we get negative 3 over y cubed. And I don't see that as an answer, but I do see this one as an answer. So maybe that's it. The other one's negative 3. This one is not one of the choices. This one appears to be. This looks like you pull the negative out in front of the fourth choice, the fifth choice. X squared over y plus y over y squared. So this is choice E, I guess you would call it, the fifth choice. Once you factor out the negative sign, you pull the negative out and you get x squared over y plus y over y squared. That looks like one of the answers there.